Hi, today I'm going to explain my classification machine learning problem. My project name is Bank Marketing Effectiveness Prediction. It is an individual contribution. Project summary. Aim of this project is whether a client is going to subscribe a term deposit or not. I have loaded the data into data frame and explored the data analysis. I implemented various classification models like logistic regression, XGBoost. So these are some classification models, and we came to conclusion to answer business requirements. Problem statement: the data is related to direct marketing campaigns, phone calls of a Portuguese banking institution. The marketing campaign were based on phone calls. Often more than one contact to the same client was required in order to assess if the product bank term deposit would be yes or not no. Thus, our classification goal is to predict if the client will subscribe to term deposit. Our project revolves around whether a client is going to subscribe a term deposit or not. If he subscribe means it's yes, target variable yes. No means if he didn't means target variable no. These are general guidelines. Let's explore. First, we'll do data description. In data description, we have to look at the data, whether the we have to look at our data type, data set, and we'll see attribute age is numeric, job is a categorical data type, categorical variable. In job, we have admin, blue collar, entrepreneur, postmate, management, etc. Marital, we have diverse, married, single, and unknown. Diverse means diverse, widow. Education, in education, we have four, basic, basic four, fourth standard, basic, sixth standard, basics ninth, high school, illiterate, professional, course, university, degree, unknown. Default. Default means whether client is as default history or not. If he has default means yes. If he didn't default means no. Housing, whether a client has housing loan or not. Loan, whether client has personal loan or not. Related with last contact of the current campaign. Contact communication type, cellular phone, month, ca- last contact, month of year. These are months. So these are our categorical variables. Campaign is number of contacts performed during this campaign, and for the client numeric includes last contacts. PDS means number of days that passed by after the client was contacted from a previous campaign. 99 means contact was not previously contacted. These are our variables. These are our independent variables. Our dependent variable Y is client act, client whether subscribed or not. Whether if he subscribed, term deposit means yes. If he didn't means no. We import these libraries. We mount our drive. This is our dataset path. We have loaded to data frame. This is our data. We have these independent variables. This is our dependent variable. These are our last 5 rows of our data set. This is our data set shape. We have 45,211 rows and 17 columns. This is info of our data set. We have no null values. Looking at the data, we don't have any null values, and We have some integer data types, and most of them are object data type. And these are our columns. Checking null values. We don't have any null values. df.unique. Checking unique values. You can see unique values in these columns. Duplicate values. False. These are our df.duplicate. We have duplicate value. We have some values here. This is to check whether duplicate values. Now we'll see, look into our data. So these are count, mean, standard deviation. With this command, it will give statistical description of our features in our dataset. Here we can see object data types description. Numerical columns. Here with this code we'll get numerical columns. These are categorical columns. Now we'll explore our data. Target variable. See, here in target variable we have two outputs, yes and no. Let's look into our data. Using a count plot, we'll get this graph. We have most of the clients rejected our term deposit, and very few people subscribe term deposit. This is very highly imbalanced data. We have ratio of 8 is to 1, 8 is to 1, which is very low success rate. Now we can see in pie chart, 88% of the people not subscribed, only just 11.7% people subscribe. Now we'll do univariate analysis on various other independent variables. Now like checking a job. In job we have most of the clients from management, blue collar, technician. The top three job profiles are blue collar, management, and technician, which contains 60% of the total records. Now we'll explore marital. Most of our clients are married. Very few people are single. Very few people are diverse. Now we'll check education. Our clients' education mostly is secondary. Some of them unknowns. Some of them are primary. Some of them are tertiary. Now we'll check default. Most of them did not default in their bank history. Now we'll check housing. Most clients have housing loan. Now we'll check loan, whether client has personal loan. Most of them don't have personal loan. Now we'll check contacts. Most of them has cellular contacts. Checking months. Most of the campaign we did during May, June, July, August. Very, very less activity in December. Now we'll check the outcome. we have very less success ratio. Most of the replies is unknown. The future indicates the outcome of the previous marketing campaign. Majority of the outcome of previous campaign is non-existent. Very few people count who successfully subscribe from previous marketing strategy. Now we'll check our target variable. Target variable is mostly comprised of no response. Now we'll check. Now we'll do analyzing our individual independent variables with target variable. We'll compare independent variables with target variables. Here we have distribution of job, management. These are the count of management people out of the only this amount, approximately 1,000 people subscribed term deposit. This is for technician. This is for entrepreneurship. We can see ratio wise, we can see we have high success rate in student category. In this is for marital. This is for education. This is for default. Housing, loan, cellular. These are it is our data. Now we'll do numerical columns exploration using vegetable box plot. We'll analyze numerical variables. This is now numerical. This is for age. We can see most of the people are in range of 33 to 48, 33 something, 30s and 40s. It is for balance. We can do for all independent variables. Now we'll just plot our independent variables. Use whether to check whether the independent variables are skewed or not. Age is normally distributed. Balance is skewed. Pay, pay is normally distributed. Most of our variables are skewed. Now we'll check correlation. This is our correlation. From the above heat map, we can see there are some numerical features which share high correlation between them. Now we'll do again data processing. These are our this is our data. This is our shape. Now what we are doing is we are creating dummy variables in order to in order to implement our models. So we are converting categorical variables into numerical ones. So if the person is married means if the row is married means it will get one. If the row is diverse means it will get one. Likewise, we'll do numerical stuff for all the variables. After after converting categorical variables into numerical one, we'll delete original independent variables. Here we are doing see here we have we are dropping categorical variables, job, education, marital, all these variables we are dropping, and uh, we included dummy variables, which converted categorical variables into numerical variables. Using this using this isolation forest, we are eliminating anomalies. This Now what we are doing is we are assigning x x to the x. We are assigning x variable to the independent variables and y to the dependent variable, that is target. Smooth our approach to addressing imbalanced dataset to oversample the minority class. The simplest approach involves duplicating examples in minority class, although these examples didn't add any new information to the model. Now we count plot dependent column by. Now we'll do train test split. This is our train, train, this is our standard scalar. We are transforming x. These are x and y train via x test, y test. These are our shapes for training and testing datasets. Model implemented. These are our models. First, we are implementing logistic regression. These are our options intercepts. These values are our accuracy metrics. Here, using this code, we'll get precision recall F1 score support. Here we are hypertuning parameters with grid CV. These are our parameters. Now we are getting our best estimator. Using this code, we are predicting testing set. These are our metrics. Now here again we are predicting precision recall F1 score. Now we are doing Now we will check with decision tree algorithm. Here we are implementing. These are our scores, metric score. These are our precision recall F1 score. Here again we are hyper tuning our parameters. After hyper tuning, these these are our training and these are our predictions for training and testing datasets, and these are our accuracy scores. Using this code, we'll get precision recall and F1 score support. Now we'll check decision tree diagram. Here we import decision tree class pair. These are our columns. With this code we'll get this type of decision tree. Now we'll see our features and feature importance. Here we'll do feature engineering. These are our features and feature importance. Using this code, we'll get here. We'll We'll show these values in graphical representation. Here we are doing XGBoost classification. We implement this one, and these are our predictions and metric scores. These are our precision recall and F1 score. After hyperparametering, we get these predictions and these metrics, these precision recall and F1 score. Again, we'll see features and feature importance. Using this code, we'll get one and we'll show them in graphical representation. We have contact unknown and education unknown is loan is also contact telephone. These have very high importance. As you can see here, 0.17, 0.13. Now we are implementing a nearest neighbors. It is one of the most basic yet essential classification algorithm in machine learning. After implementing, so it is also same like the same process like a logistic regression or XGBoost. Same process. These are our these are our prediction values. These are our predictions. These are our metrics. So after using all these predictions, sorry, all these models, we came to conclusion that for age, most of our customers are in age of 30 and 40, 30s and 40s. For balance above 10,000 rupees is like to subscribe a term deposit. The model can help to classify the customers on the basis of which they deposit or not. The model helps to target right customer rather than wasting the time on wrong customer. Comparing to all algorithm, XGBoost algorithm has best accuracy score and ROC and AUC score. So it's concluded we can conclude it as a optimal model for this project. Thank you.